compete with CTF with us. It'll be fun. No stress needed. But other than that, yeah, we workshop on Monday.
Can I advance the slides on here?
What?
It's not. You start? Press space. Okay. Space what?
Okay, no, are you showing screen?
No.
Yeah, I think
on.
Yeah.
Is that one? There we go. Now hit space. Yeah, cool. Okay. You got to present from over here because this is where the Zoom audio is coming from.
Okay, so hello everyone. I'm William. I'm the person that wasn't there to introduce myself last week.
Sorry, I was just keep profile picture. But yeah, here I am.
I'm very excited to present alongside Matt, our first workshop of the quarter. So as many of you know, this quarter we're focusing on particular field of cybersecurity, like web experts. Basically, just security attacks against websites. And so to start things off, right, we're a web experience with website development, because that's just not a thing that people will teach in high school. So I thought it would be good, to spend the first workshop just taking just this kind of slow introduction to how websites even work. And then we also have just a set of beginner challenges that we hope would be pretty approachable before we get into the kind of big exploits. This is kind of a brief overview of what we'll be talking about today. Thanks.
If you're going to hack the web, you have to understand what it is. At its most basic level, web pages are just files. We'll talk about how you get those files in a second, but usually your computer or your browser will do something, and Will's going to cover that. But once you have those files, your computer, or more specifically, most of the time your browser, will use them to create the web page that you see. Most web pages have three main technologies: HTML, CSS, and JavaScript. If you're familiar with web development, you should know what these are. But if you're not, that's completely fine. To cover them in a very broad overview, HTML stands for Hypertext Markup Language. That's the content of the web page. It describes where the text is, how it's arranged, where the headers are, as well as things like links to other web pages or images, even embedded video files, stuff like that. CSS stands for Cascading Style Sheets. That's the appearance of the web page. So that's what really makes it look pretty. That's what is the theme of the web page. You can set the color of things. You can set the size of elements. You can even do really complicated things with advanced CSS like animations. The third and final thing is JavaScript. That's a scripting language, and you can use JavaScript to control the behavior of your website. Things like sending or accepting user input and sending it with a form back to the web server on the back end. That's something that JavaScript allows, as well as dynamically updating elements on a web page.
I also forgot to mention, if you would like to follow along with these slides on your own computer, we have the slide links posted on acmcyber.com. Just go to the events tab, click on intro to web workshop, and then there should be a link to the slides.
But it's just exactly what we're showing up here. So anyways, let's start from the top. So, we have a bunch of internet, right? We have a bunch of computers that can all send and receive data from one another, right? The way that it's designed is we just send streams of bytes, just byte by byte, data, raw data,
to the network, and then it routes itself to other machines, and this is bidirectional.
Model for I guess, connecting people, they settled on like websites, like HTTP, which we'll get into. But the main idea is basically you have like some sort of central server, and the server basically has all the content that everyone else wants, right? Think of like google.com, they have a server, they have a bunch of data, and then whenever you want to like read an email or like watch a video on YouTube, right, you connect to their server and they just serve it back to you. In parallel, there are tons of other clients also performing this exact same like operations. So that's kind of the model we're looking at, like one central server, a bunch of like external clients, they're all communicating independently with the server. So you kind of have like two attack surfaces. Like one, you can attack the server. The second attack surface is kind of like other clients, like your clients. It's like a product. Kind of transfer information. Like if I want to display a web page, I need an HTML file, right? That specifies how the web page looks. How do we transfer that over like the medium, this medium? And the answer is a protocol. Like a protocol is basically just a standard way of encoding these files so that they can be sent over the network easily. And what we've standardized is this protocol called HTTP. Oh, that's right. But what we also decided on was that like HTTP follows some sort of what? Oh yeah.
Sure. Okay, so before we begin discussing about HTTP, we have a really quick note about HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure. HTTP, the regular protocol, is all in plain text, which means that everything is transmitted in a human readable form. So when we're discussing all of these examples, we're mainly going to be discussing HTTP because it's a lot easier to understand the plain text than it would be to understand HTTPS. HTTPS adds encryption, so it's not human readable, and it basically prevents anyone but your computer and the website that you are connecting to from reading your traffic. This helps prevent things like eavesdropping or tampering with any of the websites you're visiting, and it prevents what's called a man-in-the-middle attack, where somebody sits in the middle in between your connection to a website, and they can basically sniff everything that goes over there. With HTTPS, it's possible to see what websites you visit, but not the content. We won't go into detail about how HTTPS works specifically, because that's more of a cryptography subject. But just know that HTTPS is really the standard protocol used on the internet right now. If you check, say, the lock icon in the bottom, or sorry, in the top left of your URL bar in your browser, and you see a lock, that means your browser is using HTTPS. So just keep in mind, HTTPS is what's most commonly used. We're going to be discussing HTTP because it's a lot easier to understand, but HTTPS is just the same HTTP requests you're seeing, but encrypted.
HTTP, this protocol is all after like a request response format. We've just found that this basically serves our needs the best. The idea is that whenever a client wants something, they send a request to the server, and then the server should basically immediately or almost immediately send back a response. That's like the request response format. In modern web development, this ends up not being the paradigm that we always use. Like, for example, if you want your server to just send constant updates to your client, HTTP doesn't provide a good way for doing this, right? Because any sort of communication between the client and the server is always initiated by the client sending a request and their server responding. So people use like WebSockets and other stuff for that sort of stuff, but we're not going to talk about it right now. Yeah, so there are two main types of requests that clients will typically make. The first is if you want to like request some sort of content, like I want a picture of a cat. Request, and then the server is going to respond to the file, at least or if it's I want an HTML file, I want a CSS file, I want a JavaScript file. These are all requests for content that the server just gives back. The second type of request that clients will make is action on the server.
So like I want to upload a picture, or I want to transfer money from one bank account to another. They aren't really requesting content, but they want to perform some sort of action that the server then still sends back to us. Or like the image is too big for us to process, stuff like that. Okay. So like we said before, right, like the medium that we use to communicate between clients and servers are just like a bunch of bytes, like characters. So any HTTP requests and HTTP response are not like magical objects or anything. They're just basically a bunch of text. And so this is an example of what an HTTP request might look like. So the first line here is basically just a command, like I run in like the Linux shell or something for curl. Curl bin is like the tool for performing HTTP requests. Like usually we use a browser. I just use curl. And I also can see like what is the actual underlying request encoding that curl actually sends. So the actual request itself is all this. And I want to highlight three main sections. The first section is the request line. And the request line basically has components. The first one is, in this case, it says post. This is sort of like the method of the request. But there's also different types of methods. So there's a post request here. That is like we want to perform some action. Another common request method, which is called get. So it's a post get, and that's for like there's a bunch of others, but those are the two main ones that we care about. Second part of the request line is the resource or like the path. So you can see how I requested, like I wanted to view example.com/do/follow, or actually, yeah. So example.com is the domain name. That is something else. Then everything that comes after example.com is like the path of a website, right? I'm sure you're all familiar with like, visiting various paths on a website. And that is just basically by far. And then the third item is just protocol. So version 1.1. The second like main section of the HTTP request is a sequence of headers. These HTTP headers, you can think of them as kind of like metadata about the request. So like one metadata that the server might care about is actually the domain name that the client was referencing. So in this case, like example.com. There are a bunch of other headers. We'll look at like some important ones later, but I just want to show that here. The third component of a request is the body. And the body is basically everything that comes after the request line and the headers. The body is used to like encode any extra information that a request wants to make, typically like application related. So like if I wanted to upload a picture of my cat, I would send a post request because I want to perform some sort of action. And my body would kind of like be the image of the cat itself. But it would not be a header because header is metadata about the request. The cat image is kind of like data that the application cares about. Cool. So as I alluded to earlier, there are a ton of different types of HTTP requests. They're both get, post, there are a ton of others. It's honestly up to the server to decide what sorts of methods they accept. The agreed upon standard. And you'll typically come across like these other request methods like put and delete if you get into like web backend development, like the REST API framework makes heavy use of not only get and post, but also like put requests and delete requests. But again, these aren't like super relevant to like the core ideas of HTTP. Next is the second item in the request line, which is like path. Here we have some sort of standard default. Our taking CS30 or 31. And you have some sort of file system where like a path is split up into segments based on like the forward slash character, right? So /food/bar/food has three different segments, like food, bar, food. Typically how the server request is going to and decide how it should handle that request. Now, usually in a URL, for example, you don't want a space character, right? Because a space character in a URL looks kind of weird. So if you want to have like a space, what you would do is you would perform like a URL encoding. So in this case, every character is actually corresponds to like some two-letter sequence where the letters are like hexadecimal. So for example, the space character corresponds to the hexadecimal code. So if you wanted to encode that in a request, instead of typing a space directly, which is kind of non-standard, you would simply write %20, and that would be interpreted by the server as a space. Here we have a table that just shows the mappings for every single character. You can just reference it on the slides later when you're working on the challenges. But for example, that's the space. And this is the code that you care about, this column, like this column. The space is 20. The percent sign itself, the percent sign is also such a factor because it signifies the start of the encoding. So if you literally wanted to type a percent character into a path, then you would encode it. And so percent is 25, so you would write %25, a percent, which is kind of confusing. Some other things you might care about, like let's say you want to have a slash in one of your path segments, but you don't want that slash to represent actual like delineation between segments. Slash %2f. On the right, slash do something else too, but actually it's only 2 segments really. And hopefully that's like how this. That's how kind of how this server. Cool. So that's like some pairs of interest that we care about. I already talked about like the that's just like the domain name usually. So the user agent header that's sent along with most requests identifies what type of client you're using. So like every browser version will have its own finger, like have its own big long string of like user agent that identifies what version it's on and like kind of what device it's running on. And the reason why servers care about this is because if it's like some particular special device, like maybe it's a mobile server, right, has a different, the server might want a different experience for the client. So the server uses this user agent header to basically cater to every individual client's needs. And there are 2 other very important headers, and these are for cookie, like cookies. I'm sure you've like seen those like pop-ups on websites that say like you want to accept all cookies or only the necessary cookies or whatever. It's like why would you ever give me like some cookies I don't want? But cookies basically a bunch of values, like a key value pair basically. So for example, we have that's the name of one is the value. And what they're used for, which we'll get later, is they're like for authentication and also tracking, but now we'll talk about that a bit more. And if a server wants to like set cookies on the client side, so basically if it's a request, the client will always attach all cookies associated with a website in its request automatically. If the server wants to set cookies on the client to store, which is all future requests, like for example, and they would use set response. That leads me to the fact that your response is identical to a request. There's just
information. Cookies are very important for storing state when using web requests. HTTP is what we call a stateless protocol, which means that you don't know what information or what requests came before a particular request. So you don't know who's requesting a page and you don't know what they've already done or what they've already seen. So all that information has to be included in the request itself. That's where cookies come in. You have to identify yourself every time that you want to perform some authenticated action on a website. like if you're updating your Facebook status or something like that, obviously you want to be the only one who's able to do that. So that's where session cookies come in, like Will mentioned. Instead of providing your password for every single action, what you can do is you can provide your password to the website once, and the website will give you back a session cookie, which is basically a long string of random characters, which would be nearly impossible to guess. And then when you want to perform some other authenticated action, you send that string back to the website, and the website knows, okay, this must be the person who gave me the password because nobody could have guessed this string. There are some other uses for cookies as well. Besides authentication and session management, there's also advertisements or personalization to track users around the web. You've probably, of course, heard of using cookies to track advertisements, like that's what Google Ads does, as well as other advertisement platforms, or personalization, like maybe remembering the settings that you'd like across some websites. So those are some other uses of cookies as well. I'm not going to spend too long on this slide, but this is a little bit more into specifics about cookies. Besides just the name and value pair, cookies do have some settings as well. The domain is, of course, the domain for the website that requested the cookies, or that set the cookies, rather. Cookies can only be sent back to the website that set them, at least in most cases. We won't talk about exceptions to that. But that means that, you know, when you have a session ID for a particular website, some other website shouldn't be able to come along and request that cookie and steal your session ID and then go do things on your behalf. There's also a path, like Will mentioned with paths before. If you have a cookie set for a specific path, only that path on the website can access it. So if you have a cookie for acmcyber.com/challenges, then acmcyber.com/events is not able to access that particular cookie. But it could access any cookies from acmcyber.com with just a slash. So you can access higher paths, but not different paths. Finally, cookies do have an expiration date. So, you know, if you've ever gotten logged out of a website automatically, that's probably because the session ID cookie expired. And the two last things I'm going to mention, the secure thing, that means that a cookie can only be sent over HTTPS. That's, of course, useful to stop someone from stealing your cookies. So if it was sent over HTTP, it would be in plain text. And HTTP only means that JavaScript on your computer can't read the cookies. That's a security feature. All right.
The bug. So we've basically settled on two different standards for sending data and bodies. The first one, most colors also kind of old fashioned, is, you know, if you've seen like a form on HTML, like on the random HTML page, if you submit a form, right, it'll send like a request server, and obviously included in the request are like the various you know, fields that you set. So the way this is encoded is pretty simple, actually, right? You have a key and you have a value, a pair, and then you just have a sequence of key value pairs. So for example, in this string, you have two different pairs. The first one is key field 1 and value 1. The second one is key field 2 and value 2. Yeah, it's pretty straightforward. And this is what it looks like in terms of like a row once it's encoded and along the pipe. It looks like that with like equal signs and ampersands separating things. The second format that most of you will like come to probably use if you get into web development is JSON. So JSON is just kind of a more general way of specifying objects and like key value pairs. It gets a bit more like, you can do more stuff than what I outlined here. But again, we just have like two different key value pairs, field 1, value 1, field 2, value 2. This is a lot of times used for like making API requests. It's made straight from like JavaScript. JavaScript is very well equipped to like deal with JSON because, yeah, I mean, it's like kind of just JavaScript objects in general. And so this is kind of like the choice of those, you know,
I was thinking we'd just do a demo after because this whole setup is so annoying.
Finally, we have a couple slides at the end here that will help you sort of understand how a website works. These aren't specific about the HTTP protocol, They're more about broader web infrastructure in general. So the first one is called the Robots Exclusion Standard, or it's sometimes referred to for short just as robots.txt. Basically, robots.txt is a file located on many websites that includes information for web crawlers about which areas of the site owner doesn't want indexed. What's a web crawler? A web crawler is just a program or a robot that browses the web, usually to index it. This is what search engines like Google use. Basically, when you search on Google for ACM Cyber or UCLA ACM Cyber, Google has to know about acmcyber.com for it to give you some useful information about it. So Google uses what are called web crawlers to browse the internet and follow links and save some information about every website that they encounter. So that's what a web crawler is, basically. The format of robots.txt is pretty simple. You can see there's just a user agent line. The star is a wildcard, which means every user agent. You can also get more specific, like I believe Twitter's web crawler is just called Twitterbot. That's its entire user agent. And then it contains a list of allowed or disallowed URLs. It's important to note that robots.txt is not, it can't actually enforce these. It's only advisory. So robots.txt includes some URLs, and it tells the web crawlers, hey, please don't go to these URLs. But it can't prevent the web crawlers from going to those URLs, because presumably you want the users of your site to access those as well. So it's up to the owner of the web crawler to properly listen to what's in the robots exclusion standard here. And in fact, some malicious web crawlers or some tools that look for vulnerabilities will specifically start with robots.txt and go to all of the areas that they're not supposed to, because those are the areas that the website owner didn't want a search engine knowing about. So that can be very useful for you if you are, for example, trying to get some information from a website. If you check robots.txt, if you find that it exists, and you find some disallowed areas, those might be of interest. You might find admin panels, login pages, or maybe you'll just get some sort of insight into how the website is laid out. But this can be a great source of information. The second part of this is a sitemap, where robots.txt is used to exclude search engines from specific pages. Sitemaps are sort of the complement or the exact opposite. A sitemap is designed to specifically tell a search engine about pages that are available to index that should be indexed. A sitemap is written in XML, which stands for Extensible Markup Language. Don't worry if you don't know what that is. It's pretty easy to understand. And it can include some extra information like priorities or how often the page is updated. But really, the most important part is that it tells the web crawler that the web page that is listed exists and it should be indexed. Like robots.txt, this can be useful to you for finding pages on a website. If you just jump onto a website, you probably can't follow every single link on that website to find every single page on that website. But there's a very good chance that the sitemap will include pretty much all of those pages. So you can pretty easily scroll through, look at all of the paths that the sitemap links to, and see if there's anything interesting in there. Neither sitemaps nor robots.txt are mandatory, so you won't find them on every single website you visit. You can host a website and have one or both or neither of them. But when they are present, they can be very valuable sources of information to start looking for vulnerabilities or information. We should do the demo now, because
Yes. Cool. So honestly, I think we've talked a lot about it. We've shown you slides, but I think the most useful way to just get a grasp of things is just to see it in action. So we'll be not experimenting, but just showing stuff, just the various things we had here, what it looks like in an actual browser. So screen, I guess. Okay, sure. Tab is fine. And I have to bring it up to the main thing. Drag.
Hey, let's go. Okay.
Awesome. Okay.
Okay, so we're going to experiment.
screen sharing is possible. Oh, wait, no, I see. Type something. Yeah, no, it's not coming up on the screen. Okay.
moving it.
Okay, that's good.
Nice.
All right, cool.
There we go.
So I'm using Chrome right now. Every major browser offers these tools, which are really helpful for like web exploitation. Like Firefox, Safari, anything you want. I just basically just run. Like all of our challenges, this is not very much for like this workshop in particular, but in future workshops, and if you like, start really getting into the deep end. So what we're going to do is I just right click and then this option called inspect. Developer tools, like Chrome
Developer tools. There's something similar for like Firefox. Edge is the same thing.
So you can see in developer tools, we have a bunch of different tabs, and these tabs can be used to like inspect a variety of things. What do I mean? What we care about for the first workshop.
So like when you use a browser normally, right, and you visit a web page, you don't see anything that's going on under the hood, right? Because the browser abstracts all of that away from you. You just see like some sort of pretty desktop.
But if you care about what's going on, like in terms of actual raw requests and responses, the network tab records all activity for you to inspect. So we're going to go ahead and visit acmcyber.com. This constitutes GET request, right? Because we're requesting the HTML page. So you can see there's actually a ton of different requests that show up when we visit our one page. But the first one is just the actual HTML file itself. And yeah, this is the request. See, here are like lines. So we have the URL is on the request line, but we have like the request method. The status code is the header set in the response. So 200 means that everything went well. Perfect. Here are the response headers. So you can see there are a bunch of different headers, like policy. And if we go down, here we see the request header that aside from like the like the standard ones. Yeah, okay, cool. So you see user agent here. It's this is like the user agent of this browser, which is kind of, yeah. And you see at the end from /94. So these are the headers with, if you want to actually view the raw request itself, everything. That's fine. I mean, basically the headers itself and the body and like the status line, they're all shown here in like raw text in some way, shape, or form. And here you can see that for response. This is the body of the HTTP response, which in this case is just the HTML file itself. So yeah, this network hub is very useful. You can see like there's another request, get request to acmcyber.com/static/style.css. That's what makes our website so pretty, right? Like, is just what makes, for example, this like yellow or the background gray. So if this request wasn't made, then you would just have a very like vanilla looking website, kind of like the CS31 website. Like those don't have any styling at all. If you try to download the HTML file, it looks the exact same, like it's like compared to when you view it on the web, because it's just that file itself. There's a certain charm to it though. Yeah, and then some other useful files like the image, font file, and so on. Cool.
Now, let's say that you actually, you don't want to just view requests. You also want to like make your own custom HTTP request to a server.
Chrome also offers like a very nice way of doing this. So if I right click a request, I can copy it as a variety of things. So this is like a curl command. That's why I used before in some past slide. Yes, fetch. And fetch is a JavaScript function that's given to you for free in like all browsers. And it's just a function call along with like a bunch of data which represents the request. So this is the exact same request that Chrome initially made, but now we can make it on our own terms. If I press enter on the request, let's go to the network tab. At the very bottom, you can see another HTML server.com request showed up, and it's identical to the first one because we just copied the first one. Now, if you find yourself in a situation where you want to modify a request, and just a lot of one-shot challenges, you can also just, it's just JavaScript code. Like even if you don't understand JavaScript, like for example, if you want to modify a header, these are just strings. So like if I want to change, where is the okay, you can just set it. But like if I wanted to change, what do I want to change? Oh, a post request. So let me make it a post request instead. Oh, and for good measure, let's also change the header. Like, Windows, it's macOS. I don't know what that does. Okay, post. This is 404 because the main page isn't equipped to handle post requests, right? This is just for GET requests. But the request still took place. So again, the URL is htmlserver.com, but this time, right, the method is post instead of GET. And you can see the status code returned from the server is 404, which is like the error code, as opposed to 200, right, which was okay. And if you look at the request headers, browser just automatically includes like the host header, for example. So you can't customize it unless you do stuff in like yourself in like a curl command. But yeah, or the Python request, like you can just do all of these in various libraries and all. But I think that's will be the easiest for most challenges. If you really want to like get into the weeds, then I think the easiest one to do would be a curl command. If you're on like Linux or Mac OS, you can just run curl in your terminal. It looks like that. If you're on Windows,
Use Windows subsystem for Linux if you're on Windows.
Or you could just go to the CSNET, like if you actually like really want to run a curl command, you don't want to like mess around with your Windows computer, which is understandable. You can go to like the CSNET server, which you guys are using for.
From there, it'll be all the same. Cool. Yeah, cookies. Okay, I'm going to. So on the acmcyber.com website. Oh.
I'm going to log in as myself. If anyone wants to use my account, have an HTTP request that was logged. The URL is ecm.cyber.com/login, and you'll notice the method is a post request, right? Because we're performing some sort of action. We're authenticating ourselves to the server. Size code is 303, which just means redirect, because it redirects us to back to the challenges page. But if we scroll down, the actual request body, form data, there's two value pairs, name defund, password defund. The source, it looks kind of like what I showed in the slides, right? Name equals defund, ampersand, password equals defund.
parse for your and cookies. You want to look at the developer console for cookies and application. Also, the place where I ran JavaScript before. So consoles, if you want to run JavaScript and fetch command, network if you want to intersect packets, application if you want to look at cookies. I believe
That's the cookies tab.
we have one.
Session 2, and the value is this.
So if you want to add a
See?
you can like add a cookie here, like double click, you can create whatever cookies you want, right? This is all
Stored on your browser anyways. And if you set your cookie to this, it as me, and from the perspective of the distance that are served, and or you can just log in and find the fun. That's what it is.
No, I was robots.txt demo. Cool. So that's a lot of the information about the protocol. Really quickly, I have a short demo for what I mentioned with site maps and robots exclusion. So if we go to, for example, a random website and find their robots exclusion standard, we can see here's an example of the wild. The screenshot I have on the slides is actually just the first couple lines of this, so there's not that much more information to show here, other than that, hey, it exists, it's on your websites. And if I scroll down, I can find, yeah, here we go. So here are some user agents that are not star. You can see Google ad bots and Facebook on there as well. Yeah, so this is an example of .txt. If we pick another website completely at random, what?
Nothing. Go.
Okay.
So if we check out Google's sitemap, for example, also just look at /site. Number of sitemaps. They have separate ones for Gmail, ones for slides, and so on. So we can actually view a specific one, see some of the entries. Yeah, so here are all of the entries that Google wants web crawlers, including its own web crawlers, to know about. These are all of the pages that are on Google.com related to Gmail. So yeah, that's all I have for this demo. It's very short. It's just showing you where those files are located. Not all websites have them, like I mentioned. If you go to acmstandards.com, you'll see we do not have a robots.txt. We just got a 404 page not found. So it's not necessary for a website, but when it is present, it gives you some good information. That is all the demos we have. Really quickly, before we get started on challenges, we have one final slide, I believe.
Henry already mentioned it at the start, right? Yeah. But also the membership code, right?
Yeah.
Go to that.
The capsule flag signups will be closing at midnight tonight, or 11:59, because so today is the last time for you to sign up to participate in an external CTF with us. Even if you have no experience, I highly recommend you sign up. We will pair you with people who do have experience, as long as you come with a mindset that you want to learn. If you have any questions about CTFs, feel free to ask us. This is the challenge date and times, as well as the links to some more information about the challenge on CTF time and the sign up form. These are all in the slides, which you can get on acmcyber.com. And yeah, please come out and sign up if you're at all interested in CTFs. It's not a huge time investment. And with that, that's all we have. Here's the attendance code, which you can clearly tell was created at 5:40 today, about 20 minutes before you all got here. Yeah, if you'd like the attendance code, there's that. And challenges should be up and running. So feel free to start working on challenges. We're all here to help.
Yeah, also, if we notice that people are like stuck on some challenges or whatever, we might also
So like incrementally that show how to solve them actually on the big screen. So if that happens, just try to stay quiet so that people who are stuck on the challenge can follow along. But yeah, you're free to like work on the challenges.